Earlier in the year, we talked about vertical asymptotes and how we have to use the term limit and how we have to use the term infinity to describe vertical asymptotes. Well, today, talk about horizontal asymptotes, and again, same thing applies. We've got to use those terms in order to be able to describe or define what a horizontal asymptote is. So, there is a horizontal asymptote. Now horizontal is a y equals, where vertical is an x equals. So at y equals, well, let's call it c. If and only if the limit as x approaches infinity of f of x is equal to c. So if we get all the way out to infinity and we are approaching some number, some y value, we've got a horizontal asymptote. Now, the same thing would be true if we were approaching negative infinity. If we were approaching negative infinity and approaching some y value but never getting there, we'd have a horizontal asymptote as well. So we're just going to add this. This is a plus or minus, or a positive or negative infinity. And if our function approaches some constant value but never quite gets there, then we've got a horizontal asymptote. Now, maybe it does get there. Maybe you have something that goes like this. It's going like this, big, and then they get smaller and smaller and smaller and smaller and smaller. And so that, I guess, too, could be a horizontal asymptote, and yet still be a function. That couldn't happen vertically, because then it wouldn't be a function. Okay, now we've got a function. And we're going to evaluate the limit as x approaches infinity. Well, one way to evaluate a limit as x is approaching infinity is just to focus your attention on the highest order term in the numerator and in the denominator. Because if x is a huge, 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 huge number, then x squared is huge. 13 is not significant, and I can cross it off or ignore it. It's still there, but I'm ignoring it because it is so insignificant compared to these infinities being squared. In fact, the term itself, x, or three of those x's, are insignificant. Because x squared, a billion squared, is so much bigger than a billion. A billion squared is so much bigger than 3 billion. So it comes down to what's the ratio of these two terms. What is the ratio of 8x squared over 6x squared? Well, even the x's, they would factor out to be a 1. And you would be left with 4/3. And so what does this tell you about the function f of x? F of x has a horizontal asymptote at y equals 4/3. Now, let's practice describing these. Describe the horizontal asymptotes and the reasons why you say there's a horizontal asymptote. So in this, with this graph, with f of x, which is our blue squiggly here, where are the horizontal asymptotes? Well, I think I'd say at y equals 2. And then if I'd have to give a reason for it, I'd say because the limit as x approaches, what are you thinking? Negative infinity of f of x is equal to 2. And we'd probably also say a horizontal asymptote at y equals negative 1. And again, we have to use limit. In this case, x is approaching infinity. And that is equal to a y value of negative 1. So just to reiterate, using limits, using infinity, those are requirements of describing or defining or explaining why something is a horizontal asymptote. All right, now we're going to use limits and infinity. We got horizontals and verticals in this guy. So since we're kind of in the mode of explaining horizontals, let's do that. Now horizontals, you got a maximum of 2. And in this case, it appears as if maybe we do indeed have 2 horizontal asymptotes. This one's kind of interesting down here. You can see the horizontal asymptote is y equals negative square root of 2 over 3. It is possible for the function at some point to actually equal that, and yet still have it as a horizontal asymptote. So y equals negative square root of 2 over 3. And we have to give our reason. X is approaching negative infinity. And looks as if we're going to get close to positive as well. So y equals square root of 2 over 3 as x is approaching positive infinity. Now verticals. We've got ourselves a vertical asymptote right here, don't we? So there's only one vertical here. And verticals are always x equals, in this case, x equals 5/3. And our reason for that, well, it's one of two things. We only have to state one of those two. I'm going to say because the limit, as x approaches 5/3, and now I have my choice of saying whether I'm approaching from the positive or the negative side. I'll choose the negative side. The limit as x approaches 5/3 from the negative side is equal to negative infinity. Could have chosen the other side and said it was approaching infinity. Again, limits and infinity, the most important pieces of those descriptions. Horizontals and verticals, if we're given this in algebraic form. Well, we're in horizontal mode, so let's do horizontal asymptote. Biggest degree on the top, we've got 9x to the 4th under the square root. Biggest degree on the bottom, the rest of this insignificant. And if I take the square root of 9x to the 4th, that would be 3x squared over 5x squared. So I'd have a horizontal asymptote. Oh, 3x squared, sorry. Horizontal asymptote at 3/5. Y equals 3/5. Because the limit, as x approaches infinity, of f of x equals 3/5. Now, I better check to see what's going on at negative infinity. And I think if I went to negative infinity, since these are even numbers, we're going to end up with positive values again. We're still going to have 3/5. All right, what about verticals? Well, let's see. Let's get rid of this crossed off stuff. Now I'm going to focus my attention on what makes the bottom 0. I'm going to try to factor this. I hope I can do it. I have 5x and an x. I think I'm going to have a +1 and a -1. And that will indeed give me 4x as my middle term. So I think we're okay. So the numbers that make the bottom 0, x equals 1/5. X equals -1. Now, let's check something out. Let's put a 1/5 up here. If I do that, I'll be taking the square root of 9 and 1/5 to the 4th power, 625, minus 4/5 plus 1. Well, I think we do get a positive value, which we can't take the square root of. So 1/5 is in the domain. So I'm going to say that the limit as x approaches 1/5, now I should choose a side. Now remember, the top is always going to be positive if we have a number in the domain, because it's a square root. The bottom, if I choose to approach 1/5 from the positive side, it's a number a little bit bigger than 1/5, which makes this slightly positive. This is positive, and so my limit is going to be positive infinity. What if I approach -1? Let's approach -1 from one side or the other. Let's approach that from the right as well. Now, if I put a -1 up here in the numerator, -1 to the 4th is 1. So I'm going to have 9 plus 4 plus 1. So yes, I do get a positive value up there under the square root. This is in the domain. If I choose like -0.9-ish, this is going to be negative. This is going to be positive. And negative times a positive is going to be negative infinity. Because the bottom is very close to 0. And just for practice, let's just evaluate that limit. They don't ask us about horizontals or verticals. I would cross off things that are insignificant. Just say that's equal to 1. So that is our discussion about horizontal asymptotes, and also a refresher on vertical asymptotes.